For example 2, just a couple little differences in here. This case I'm not giving you the reaction, you're going to have to figure it out. And I'm giving you the units of atomic mass units. So we'll have to do some conversion in here. But the mass of zirconium-93 nucleus is 92.88 atomic mass units. Determine the binding energy of the isotope of zirconium. Well, the first thing we should do is figure out what the total number of protons. We've got zirconium, and if you look for it on your periodic table, zirconium is element number 40 on the periodic table. So it's 93 nucleons, 40 of them are protons, and the symbol is Zr. So we're going to break this into the 40 protons and 53 neutrons. So again, what we need to do is find the mass defect. So change in mass equals 40 times mass of the proton, 1.6726 times 10 to the negative 27 kilograms plus 53 times 1.6749 times 10 to the negative 27 kilograms. And what we're going to do is subtract 92.88 atomic mass units. But what we want to do is change this to kilograms. So we're going to times this by 1.66 times 10 to the negative 27 kilograms. So we had to get everything into the right unit system. That atomic mass unit conversion is on your data sheet. So again, be very careful when you're punching this in. 40 times 1.6726 exponent negative 27 plus 53 times 1.6749 exponent negative 27 subtract 92.88 times 1.66 exponent negative 27. Hopefully I punched everything in right. And you get a change in mass here equal to 1.4929 times 10 to the negative 27 kilograms. And what we're going to do is find the binding energy. So E equals change in mass, speed of light squared. Multiply that number, 10 to the negative 27 kilograms times 3.0 times 10 to the 8 meters per second squared times 3 to the exponent 8 squared, and you get 1.34 times 10 to the negative 10 joules, if I was just going to stay to 3 significant digits. Again, I'll leave this one in joules since the last one was in electron volts. We'll leave this one in joules. This one isn't asking for the binding energy per nucleon, So I don't have to divide out by the 93 nucleons in zirconium. I just need to find the total amount of energy or total amount of mass that was converted into energy in this reaction. And again, 10 to the negative 10 seems like a small number, but in comparison, that's just out of one atom. That's a huge amount of energy. We were looking at energies before of 10 to the negative 15, 16, 17 in some of our previous lessons. 10 to the negative 10 is 1,000,000 times stronger. That's a lot of energy. Just be very careful in calculating that change in mass. The change in mass is always the thing that throws people off the most. Make one little sign error in there, or you make one little calculator mistake with all the multiplication and subtraction and addition, really throws off the change in mass. And then when you multiply it by the speed of light squared, it becomes a very big error in your question. So this one's 1.34 times 10 to the negative 10 joules.